My name is Nick, and I'm a Ruby on Rails developer for the last 6 years. That's a lot. And for the last year, I've been working with a company called SoftSwiss. It's a general partner on this conference. And I want to talk to you about scaling again, but we go from another direction. So let's talk about SoftSwiss a little bit. So if you guys don't know, we are white label solutions for Casino. We provide you with a setup and deployment and compliance with game building licenses if you want to. So if you want to set up a Casino, you can talk to us after the stand-up, after this talk, and we might get you organized. We have a lot of load. We have 20 million bets on all our sets of casinos, a lot of integration with different gaming providers, and we also got you covered on gaming licenses. There are, I guess, 5 or 10 gaming licenses we are currently support, and we are working on supporting even more. And that's a short introduction about SoftSwiss, and let's talk about Ruby. So what does a simple setup looks like? It's just a Ruby on Rails process on a separate server. Obviously, in real-life scenarios, it doesn't work like this. You have to partition your database and queues into separate instances in order to share a load. And of course, you still have to spin up a Ruby on Rails application. You probably know this. You've seen this 100 times and even more. But what happens when you add some real-life scenario, some real users to this application? And you have to introduce some other dependencies you might not have thought earlier. Like, for example, we have to oblige to Maltese gaming license. And in order to do this, we have to block a user on a subset of Casino. So if he or she decided he doesn't want to play and gamble, we need to block this user on every Casino we have. So this is why we introduced PlayersDB, PDB for short, and we also can use it for data aggregation and just to push configs to different casinos. So it starts looking like this. You have all the different setups here. It's all the different casinos. And you push data from casino to PlayersDB and vice versa. It gets complicated, but when you add a lot of users to this equation, on our biggest setup, we have 500 requests per second, which generates a lot of data onto our servers. Yeah, we hide it under Cloudflare to protect from DDoS attacks, but still it's a lot of stuff to handle. And obviously, it's not going to end well with this architecture. We sometimes get slow response times because you have to iterate over a lot of data. Our database can grow really, really big. Like on our biggest setup, we have a database more than 1 terabyte. A lot of indexes, therefore slow writes, slow reads. And you have to do something with this. And also, yes, our application is unfortunately monolithic. I'm really proud of this GIF. I really like it because it shows how I develop a monolithic application in Rails. Yeah. So we have to do something with this, and what we've done, we try to split the monolith apart. It kind of worked, but not really. So yeah, we split the monolith. We moved gaming integration from separate server written in Go language, Golang, which is now a separate business which we can sell to our customers. We took some time to work on indexes to optimize our database, and it's also helped. We are working on ZB partitioning right now. We are trying to move this big database, which weighs over 1 terabyte, into small packets and use only recent partition as an active. Yeah, you probably know all this stuff if you encounter scaling problems. But there is something that we want to do. We want to do more. We want to be fully scalable. Like if you want to take our application and grow it 10 times bigger, what should we do? And we decided that we should split this monolith apart, as I told before, into separate services. And you put them into containers and just put them in the cloud. And in order to do this, you have to have a reliable message bus between all those services. And usually people done it with RabbitMQ, but unfortunately, RabbitMQ doesn't scale well. And our head of engineering always told us one particular example, like if you have a cluster with 3 nodes in RabbitMQ, yeah, that's a fine slide. If you have a cluster with RabbitMQ, and you push down, shut down first node, shut down the second node, and try to spin up the second node again, you get a broken cluster. Because RabbitMQ doesn't know how to connect to this. And of course, you can get split brain scenarios, and they mention it into documentation that RabbitMQ is not really partition tolerance, network partition tolerance. So we have to find some other ways to deliver messages between our services. And we introduce you Apache Kafka. It's not Apache Kafka, it's Franz Kafka in Prague. Have you guys been in Prague, anybody? Yeah? Did you find this statue? It took me like 2 hours to find it because it was located in some different place and I was just circling around this. But yeah, it's Franz Kafka and Apache Kafka, which is named after this Czech writer. So what Apache Kafka is, short overview. They like to call themselves a distributed streaming platform, which is basically looks like this. It's a very, very high level overview of what Apache Kafka is. And you've got your producers that push to a Kafka broker. It's not a cluster right here. And you consume your messages from this broker. More detailed explanation is something like this. In a cluster, you can have several brokers. Each broker consists of a topic, and topic is where you push messages to. So you can have several topics into one broker. And topics can be named like users, posts, payments, something like this. So it's a place to store your data. And each topic is divided into partition because of redundancy in order to get up after failure. So you have a separate partition, and each partition can be made a leader partition in this topic, and it gets copied over another topic into another broker. So if this topic, if this broker goes down, we have another one with exact same data. That's how you does not lose messages if anything goes wrong. Yes, that's all. And each topic consists of partitioning, as I said before, and you write to all the partitions here. They all synchronize between one another, and consumers just read from these partitions. Let's go more. Oh yeah, Kafka does not delete messages at all. It deletes message after 7 days, or if they wait more than 1 gigabyte. But you can configure that, and eventually just does not delete any message you received in Kafka. So what we want to do with Kafka, we want to test it on the smallest scale possible and check whether or not this suits us, whether or not we can use it on a bigger scale. So we choose our smallest project and try to implement Kafka in here. And remember I told you about PlayersDB stuff, where we push data from different casinos. We decided to implement these messages through Kafka. And usually, if you choose approach with RabbitMQ, you would have to write a lot of producers code to push messages after the transaction to PlayersDB. So you have to write a producer code on Rails side, and it might fail, and it might go wrong something. And there is a lot of just development stuff you have to do. And we found another solution. We just connect to transaction logs from Postgres, and we use this Debezium. It's basically a wrapper from Val to Kafka. And that relieves a lot of burden from our shoulders, because Debezium just connects to Val logs, and it transforms this into Kafka streams that are readable by Kafka. So you don't have to write any producer code on Ruby on Rails side at all, which is really neat. And also you get you can be sure that all the messages that are committed to database can be read from Kafka, and you will not lose anything in the process. Yeah, also when we try to implement this Debezium feature, we found out that it does not support all the data types. Like, for example, we have inet type to store IP addresses, and Debezium did not have this supported, so we made a small contribution to the open source project. Hooray. It does not support DLL changes, but it's not important for us. So yeah, now this path is now covered by Kafka, and it works really great. We didn't have any outrages for the last 3 months, I believe, when we implemented this in production. And we got a lot of other stuff to we got other profits from this. We can now provide real-time reports from finance team, which improves our processes in the company a lot. We tried Kafka in production and it worked, and we liked it, so we want to improve. We want to build on it even more. So yeah. And minimal development effort from Ruby on Rails side to produce messages, which is really, really cool. And what we've got in mind is to continue splitting our monolith apart, because now we have a reliable message bus that can scale well and support message handling between all the services. This is some ideas what we might do with our platform. Like, we have an idea what to do with payments. We just split them up and move to several instances, several server, business intelligence stuff to generate reports separately from gamings and our platform. And yeah, we might want to get rid of RabbitMQ already to just handle everything through Kafka. And I guess that's about it, a small introduction in SoftSwiss and how we do stuff with scaling. That's all. Thank you.
Thank you. We have questions over here.
Yeah, thank you for the talk. My question is not related to Kafka, but you told us about your own PDB, and you mentioned that its creation was inspired by some licensing stuff, but it all sounds like business logic, not database layer. So I would like to know more why have you chosen to write your own database?
It's not a database, it's an application in Rails, written in Rails. It has a separate database. So we have a separate set of casinos. I might want to switch to this slide. Like, for example, here. And each casino has its separate database. And you might have some user which is not allowed to play, say, here and here. And this user is identified by email or phone number. So, but it's different users because it's on a different database. And we have to aggregate this to separate, like, aggregation database. It also has a Postgres inside, and it's basically a Rails application.
Yeah, so yeah, it explains all. Thank you.
Thanks. Yeah.
Any more questions?
There is somebody else wants to ask me.
Yeah, here you go.
Okay, thank you. First of all, thank you. And I'm glad here to somebody else also using Debezium in production. So my question, you said you got almost infinite scaling, but how about Debezium scaling? It has processing in one thread, Val. So how you handle that? Do you have benchmarks? What throughput? So fine.
We didn't have benchmarks because our load is not that big. Like we've got, if I remember correctly, about 200 requests per second to PlayersDB. So we are not concerned about this right now, but as I read in the Debizium documentation, it's also distributed and scalable, so it might work.
Yeah, so it might work. Okay, thank you. One more follow-up question. So did you test any failovers? What happened if it fails? How do you restart? Do you have?
We put this into Docker container. It's handled by DevOps, which is not here right now, but they say that it has a great failure capabilities if anything goes wrong.
Okay, thank you.
They say.
They say, yeah.
Okay. Did you check this?
I didn't try to push down our own casinos, so.
That's true. I have one question here.
All right, so you said that you mainly use Kafka for reporting, and so it's good for you that you are good receiving all the messages from the topic, and RabbitMQ allows the consumer to select what exact messages from the topic, what attributes can it bring, and Kafka just can't do that. And as you said, on the consumer side, you want to be as generic as possible. You even listen to Postgres logs.
Yeah.
I didn't get that far on that step, but you do want to have as generic producers as possible. So do you know any solutions? Can we have a generic producer, but can consumers subscribe to just several messages? Is there any hack? Can you do this somehow?
If I understand correctly, you're asking about routing. RabbitMQ has a decent, really cool routing, and you can subscribe, yes, to different parts of the message. And Kafka, we didn't find any solutions for this, but we didn't need, because what we need is just to catch all the logs and to parse it somehow. And so yeah, if you need this really good routing in RabbitMQ, you probably don't want to switch to Kafka.
All right, one more.
Probably. We have time.
Yeah, we have time for one more.
You do.
Thank you for your talk, and I have a question about, did you face any problems to scaling Kafka and deploying, and maybe some supporting services about about how does mean that service discovery service
Service discovery.
with the Kafka? So any issues in production? Do you face it? Can you?
It bothers me to say it, but we didn't. So it's probably we didn't test it maybe to its limits, but from theory, from what we read about Kafka, it might get its job done better than RabbitMQ because it has failover capabilities, because it has replications, because it has different clusters and brokers, and it's designed to handle this load from the start. So that's all.
All right, so thank you for your talk. Let's give an applause.
Thank you.